Problem 54. Find the derivative of arcsine cosine x over ln x. Note here that the cosine x over ln x is the argument of the arcsine. It's not a product rule, this is a chain rule. So for starters, remember that if we've got arcsine of u and we take its derivative, this gives us 1 over the square root of 1 minus u squared. And then applying the chain rule, we multiply by the derivative of the inside. So it means on this problem, when we take our derivative, we've got 1 over the square root of 1 minus u squared. So cosine x over ln x squared. And then we're going to multiply by the derivative of what's on the inside. So inside I see we have a quotient rule because cosine x is being divided by natural log x. So remember the quotient rule. This gives us v times u prime minus u times v prime over v squared, where our u is cosine x, our v is natural log x. So computing their derivatives, the derivative of cosine x is negative sine x. The derivative of natural log x is 1 over x. So now plugging these into our product rule, or our quotient rule, we square the denominator, so we've got ln x squared, and then we've got v times u prime, so negative ln x sine x, minus u times v prime, cosine x times 1 over x. Now generally we don't like to have this complex fraction here, so what we'll do on this step is get rid of this x in the denominator by multiplying numerator and denominator both by x. So that leaves us for our derivative 1 over the square root of 1 minus cosine x over ln x squared times, now in these parentheses we'll distribute this x through to both terms, so this gives us minus x ln x sine x. On the second term the x's cancel, we've got cosine x. In our denominator we have x times ln x squared. And then finally here, I don't want to have this fraction inside of a fraction. So what I'll do is I'll multiply both the numerator and denominator by ln x. So that way we can get rid of the ln x that's down here. Now multiplying these through, we've got natural log x in the numerator. Our denominator, when we distribute this through, first we've got to make sure that this is in a radical. So we can rewrite that ln x as the square root of ln x squared. Now this is in a radical, as is this, so we can distribute that ln x squared to both terms. So we've got ln x squared minus, here the ln x squared and the ln x squared cancel, and we've got cosine x squared, all times this expression in the parentheses, minus x ln x sine x minus cosine x over x times ln x squared. And then finally, we can reduce the ln x's. This ln x will cancel with one of these. And so all we have left over for our derivative is 1 over the square root ln x squared minus cosine x squared times negative x ln x sine x minus cosine x over x ln x.